Hi Kushal, Happy New Year. Waiting for a couple of more people. Hello Avni, how are you? I thought कोई आया नहीं है तो मैं ऐसे रुकी हुई थी. Okay. All right. Uh, oh hey, lots of people suddenly now. Okay. You must be wondering why I'm looking at quarantine bread. And I'm not looking at it because I'm interested in baking some, but I think I've done that meme trend already. But I found out today while researching for recursive computation that, yeah, so good to see you too. Sorry, my chat streams are a little bit slower, so I'm seeing the messages a bit late. Yeah, new mic also. Sasta hai, but acha hai. So, no, but he was there last time when you joined Kushal. Maybe he was just not in the view. Yeah, so this uh, is actually also part of recursion because I don't know if you guys did somebody here bake sourdough during the quarantine before or after? Raise hands in the chat. Sorry. Uh, so Yugen sleeps a little early now, but I don't know. Sometimes I find that other kids are crying, and I feel like it's Yugen. So are others also into bread making? Okay, anyway, forget it. So I'll start off by uh, stating that I was quite excited about the January stuff, but the prompts were a bit too tough for me to follow because I'm not of a mathematical background, and it was quite evident to me pretty soon that no, this is not going to happen. So, but then I was like, hey, why am I like shying away from these concepts? Because I'm sure we can all think about all of this. And anyway, I went to Coding Train and I saw his little tutorial. But it got me thinking where one could use recursion. Rule 30 के बाद बंद कर दिया. Okay. So yeah, it got me thinking about what recursion means and like why is it so sort of prevalent in these kind of tropes of creative coding that we see. So I mean, obviously it's not very difficult to execute, especially in that recursive tree format that we see, which is very popular. I don't know if this is the right thing. Like this one. Where did it go? Creative coding. I don't know what to write. Like these kind of things, I'm sure you guys must have seen. So it's not very tough to kind of execute something like this. And obviously, you can do a lot. Like people have done all these kinds of incredible ferns, and like I'm sure there is some sort of usage for it in game development and things as well. But I was sort of wondering why do we do this, and like why the hell kind of. But the thing is, why the hell not? So these are some really interesting facts about the concept of recursion. And the very brilliant thing about it is it ranges not just in math, but it also goes into linguistics and very very commonly in art, which we may or may not have seen around us as well, popularly also known as this droste. I don't know how to pronounce this, droste effect, or mise abîme. Raya, maybe you know how to pronounce this, and I don't know how you tell us though. Where there's like this, the thing that you're representing gets re-represented within that. Thank you, within the picture. So, for example, in this image, you see that she's holding the cocoa, and she's there in the picture, and she's there in the picture. Like, hey, thank you so much. And This kind of I think the another very common one is the one with the with that image of that butter image, like land of butter or something it's called. I don't know. Some of you might have seen that. Let me see if I can find it like on the internet. Land of lakes. Yeah, that was fast. Kushal, you are really, really fast. So, oops, land of lakes, butter. Where very problematic image, but like she's holding the butter, the same block of butter, and then it goes in and in and in. So that's what I found, that the relevance and the recurrence, the recurrence is fairly common, and we see it quite a bit around us. And of course, it's very common in nature as well, like to see. And I'm sure we've all seen these like Mandelbrot and fractal kind of images around. I think Abhinay did a very beautiful set of 3D ones, I think some months back, with something called Julia set, which is also part of a similar sort of idea of recurring fractals. And I don't know if you guys saw that TV series Devs. They made a whole room that looks like this Sierpinski carpet as well. So some exciting possibilities. And where I was really interested, which I found out today as well, that recursion is very, very sort of a very important term in language as well, where oh, you should. It's a really good. I mean, I liked it a lot. It was quite a good show. SP. It was on. I saw it on Hotstar. Okay, I didn't like. Yeah, the spelling's right. So it's a very complex sort of an idea about language, but to think of it simply is, and this example is really nice, where they say Dorothy thinks witches are dangerous. So witches are dangerous is already a sentence, and you added a word and a noun to it. So it's noun, word, noun, and then word, and then I think this is the adjective. So similarly, like it could become Dorothy thinks that, Toto suspects that, Tidman said that. So there is this self-referencing within it, and basically that is what we'll do today. It's oh yes, recursive humor. I mean, they've kind of used it now in science and technology books, where like they'll put a reference for recursion and then say, see recursion. Perhaps, I don't know, like maybe people who do stand up have a way of like bringing that reference back. I don't know if it could be really like mapped so accurately to that. This is also a very popular image you may have seen around. Again, it's the Sierpinski triangle. I don't know if we'll be able to make this today, but let's see where it goes. Like, as you can see, I have not even opened p5js currently. So, oh wait, I forgot my pen. Hold on, sorry. So, yeah, so this is what we were talking about. So I just, oh, and also, if you guys remember babushka dolls from when we were little, I'm sure you were a young person in the 90s, you have, and spoke, like there was some English spoken at your home, there was a reference of some Russian materials in your home, like books, I don't know. There were those 5 rupee books we used to get, which were, yeah, so this is also kind of recursive in that sense. So now I'll just like trustily open my Paint app because why not? So so consider it in terms of a very simple format that we'll try, that we'll just make a circle, and we will use a simple rule and say that let the circle be just a tiny bit smaller and a tiny bit smaller and a tiny bit smaller and a tiny bit smaller, and then we'll repeat that same format once to the left and once to the right. Now obviously when you're doing something that's repeating itself, it implicitly will try to constantly repeat itself. So you will be stuck in an infinite loop. Now, obviously, your computer is not so clever to know that it needs to stop. So in context of that, you'll just have to put a simple rule that you say that, hey, do this, maybe you say do this 10 times, or you say that do it until you reach a little circle which is just say like 2 pixels in diameter or something like that. That could be the sort of easy way to kind of limit that recursion. So we'll quickly jump into P5. This we'll just use circle and line today, and we will use a bit of a custom function, but don't be too scared of it. It's not going to be too big a deal. So we'll just use whatever is our setup here in the canvas. I have to be a sincere person and log in. Okay. So how we can think about it is that one can just like easily draw a circle which is in the center with like say 100 or maybe even 250 as the radius. Perhaps we don't want the fill to see this particular thing going. And then one could just put this as a function on its own. It typically runs like an hour or more, but that's fine. I mean, the recording's always there, so you can pick up wherever you left off. Depending on how much Kushal and Himanshu push me, sometimes I do it a little longer. So what we could do is quite simply make a little function that says draw circle, and then I want to give it an x location, y location, and a diameter. And I'll just add this circle here. The reason I'm doing this is not because I just want to annoy you, but that now you'll see implicitly how it works in this particular context. So what I've just done is I said that, okay, we'll just make a custom function which allows you to put an x, y, and a diameter. So, I mean, which is not very different from putting in a circle, but maybe when your artwork becomes a bit more cool, bit more complex, you may see the sense of using this. Hello, how are you? So I know it's been annoyingly long. So we'll just revert back to that same thing. Now all I've done is I just took the same draw circle, and instead of the x, y, and the d, I just added a bunch of numbers. Now this could be anything. Now if I wanted, I could make this like 10, 100. So this would give me another circle which was at 10, 10, 100. Or so you get the basic idea, right? So now, I'm running this basic draw loop now, and the draw loop is this sort of, not draw loop, I'm sorry, this draw circle function. But what would happen if I made the draw circle function sit inside the draw circle function? So already you see that I'm repeating the rules for it within the rule for it. Is that sort of understandable? I don't know. Nobody's responding. Okay. So, yeah. Okay. Yes, recursion. So let's see what happens when we do this. Okay, so obviously now, as I explained to you, that we need to have a limit. So it's already told me that there's an error that, dude, you're just doing this too many times. So just kind of take a chill pill. Okay, wait. So we were just making the draw loop here, right? I mean, not the draw loop. Maybe I should just call it something else. I'll call it make circle. Then that'll be easier. I made this function called make circle, and in that I just gave one simple rule. I told it that if somebody gives you these arguments x, y, and d in numbers, you make a circle for me based on those particular arguments. So this gave me this circle. I could have made this anything. I could have said, as I mentioned to you, I could have said 10, 10, 5 or 4 or whatever. So it would have given me like a little tiny little circle here as well. So in that context, it's a very this is a very simple thing that we've done right now, that we've just said, okay, pardon me, make a circle at this particular point. So what I was trying to explain was that when we were looking at this diagram, I just gave it a rule that you make a circle, and then you make the circle again, and you make the circle again, you make the circle again. I just added one extra rule. I said that every time you draw that circle, you make the radius a bit smaller. Like you kind of, maybe you half it, or you know, like you third it every single time. So say if we go half, because my math is really bad. So say for example, if this was a circle with a radius of 10 and I told it to half it, then this became 5, this becomes, and then what does this become, 1.25, and so on. So we then need to tell it to stop at a certain point. So then I could say that at a certain, is this correct? Is my math right? I don't know. So at this point, just stop you making this rule. Okay. So right now, I don't have any rule of that sort here. I've just said just make the circle. But what would happen if I just took the same rule and I put it within the rule, right? So which is when we played out this particular code, it threw an error. It said that, okay, you know, it can only do it so many times. And even if I did it with, say, suppose, as I was saying, we would half it. So say a divide by 2, for example. So now you see that they are becoming smaller and smaller, but it's still giving me this error. It's saying that, you know, boss, what you're doing is not correct. You know, get a life, like be a little bit more considerate to me as a computer. So I would say that, okay, if the d is d, which is the diameter, is greater than 2, you keep doing this rule. So I'm just giving it a bit of a like a breather, shall we say. So now that kind of error has gone away, but this is but this is still not where we want it to be. What we saw here, what we were trying to do is to kind of make the circles on both ends and then make them a bit smaller and smaller. Oh wait, I wanted to add these links here so that people can, if you joined in a bit later, I was just kind of like running through some interesting references around the word recursion, and the particular one that you should all see is the main link, which includes quarantine sourdough bread. So we'll go back here, and then we say, okay, in the x direction, you make it go like, say, by a certain amount. So since we already have like d as a function, maybe I'll do like divided by, say, like 10 or whatever. Oops, what did I do? Oh, sorry. So you can see it's like moving towards the right. Yay. Okay. Or if I just kept it d, then it was so big that it's like moving out of the screen, right? So I'll just maybe like keep it at a 4th. I don't know. Okay, maybe a 3rd. Okay, that looks a little bit better. And then I wanted to go minus as well. So I could just very easily repeat the code and put a minus instead of a plus. So now you see exactly what we were doing. Now it started to like make this unit. It makes 1 unit, and then it makes these little 2 units, and then within that it keeps repeating that whole rule that we put, and it only repeats the rule until the diameter of the of the circle is 2. Like if it's less than 2, it stops the rule. Otherwise, it goes into a crazy kind of a loop. Now, I'll try it, but it did make my computer really slow the last time I did this. But we'll also extend it downwards. What is this? Cost container within. Oh, is it so? That's very interesting. I didn't know that. I think I'm gonna find out more about this. Do you have any links, Anurati? If you're on your system, maybe you can share something. So okay, so now it's moving downwards as well. And I think you may recall that we saw an example like this in the recursive thing, which was the Sierpinski triangle. I mean, it's the other way around, but conceptually, it's pretty much the same thing, right? So yeah, so now you're kind of getting this idea. Like, is it? Are you able to understand what's happening? Is there someone who's kind of a bit? Ooh, let me check this as well. Oh, sorry. How do you guys know all this, dude? Okay, I have to really properly read this and understand, but okay. So it seems very exciting. Second para on the top, okay. Aha, okay. Okay, very interesting. This is so cool. So see, this is why I was thinking of this is the way I was thinking of today's session, that we'd be able to like engage with those prompts in a sort of more deep way and not be stuck with the math, because people like me then are easy to let go, because we're like, अच्छा इसमें हमें कुछ engaging नहीं लग रहा. So thanks Anurati for this super cool reference. That's a good goal. Yeah, a bunch of geniuses on the stream today. Okay, so we've got the basic sense of this. I'm just going to save it and share the link if anybody needs it. Right? So this is, maybe if we did it in the minus, yeah, then it's kind of giving us this ulta one, because typically in the real world, when you do coordinate mapping, sorry about this, nobody does it in a diagonal plane, but so everyone does it upwards this way and then sideways this way, but p5js does everything the other way around, where it is downwards this way and sideways this way. So in that context, it just needed a minus. So I mean, now for us, this was currently a circle. I could have easily done this with a square as well. And it would have given me recursive squares. So I mean, now it's up to you, like how you like to play it. In fact, I was trying to do it with text as well, like with the text size that was D, and then text that said whatever, and then give the XY coordinates. But I don't know what happened. I have to figure out what was the issue. Maybe somebody can try it and share a sketch in the in the chat. So this is the first bit of it in terms of conceptually what it does. It just takes a rule and then reapplies the rule to itself, and we could give it a certain kind of like let's say a container to say that, okay, limit yourself to this much or whatever that might be. I think many of you, I'm sure, like me, are followers of Coding Train, and he has this whole series called The Nature of Code, which I've never been able to do. But fractals are a part of that, and I'm sure we have all seen this stupid broccoli photograph everywhere with the fractal design on it. So, you know, there you go. And it also kind of like does it in the cross sections to broccoli. So anyway, so these are better ones, I guess. I hope it tastes as good as it looks. So this is basically this concept that we were looking at. Now we'll just kind of quickly look at the recursive tree, because oh, okay, I think you're spending very little time with computational creators. Like, I'm pretty sure every week somebody adds yeah, even I think Abhinay's project, the one he did with the Julia set, was Abhinay, was yours Mandel box, the Julia set one? Broccoli is very tasty. I love broccoli. Yeah, Koparji came in now in the pink. Okay. So we'll just quickly look at a recursive tree, and that was pretty much what I had planned for the day. So similarly, like if we are looking at it in terms of a tree, those were Julia sets, okay. So if we are just looking at that kind of a tree, okay, no green for tree, purple tree. I mean, one can assume it to be like a single branch, and then two things are branching from it, which is basically like our main circle, and then the two smaller circles, and then two branches from that which are a little bit smaller, and then two from that which are a bit smaller, and so on, right? This is Sonic Pi Wali Raya. I don't know whether that is the correct reference to give about Raya. Okay. Yeah. So we'll just start off with this idea. So we'll start off with a line like this, and then so that's sort of, in a way, you can think of it as rule 1. No, don't say that to Nanditi. She loves Sonic Pi. But I think she's now more inclined to try Foxdot. So this is, say, suppose this is rule number 1. The second rule would be that start from this point, and then like do a little bit of a rotation, and then do the same line again. So the rotation is rule 2, and then making the line is whatever, rule 3, and then kind of repeat that in a sense. So we'll quickly think about this. Like, maybe we just need that first line at the bottom, which could be like say half of the canvas and at height, and then goes back to, like, say this goes to 300, so that's like 100 ka height of the line. So I could very well give the length of the line like a variable. I could just say, like, I don't know, length L. Length we can't keep. I don't know, branch BR, okay, and then I'll say 100. So here I could just minus it by the branch length, which would give me the same thing. This is basically now, if for Kushal, I don't know if you're sort of somewhat new to P5, height just refers to the whatever the height of our canvas is. So you can just refer to it as a fixed number. So here it's 400. Say, for example, if my height was 600, it would still give me the same result, because it's using that canvas detail as a fixed terminology, and then varying the number according to whatever our name was for it. So this is the sort of the first line, and then one would assume that to make the next line, you do a rotate and then make the line again. So we could, so we could just again kind of consider maybe like a branch function, which where we put in a like a length for the size of the branch, so that, for example, here we could say whatever, shall we continue calling it br? Maybe we can. And what we do here is we just add this back in here just to see how it's working. And then here I would say branch, and then I would say 100 here, which is what I was going for. And it'll still give me the same thing, right? So now I'm starting at a really low point, like within the canvas. So just to kind of give myself a bit of sanity, I think I'll just say that I'll translate it to 200, which basically means the whole canvas will shift. And then, whole canvas will shift and to the right by 200 pixels. And we'll have, where will the height be? The height also comes down. Does it go to height? Let's see. I don't know if this will work though. So what I want to do now is, if I want to say 0, 0, 0, and then minus br, it should give me the same result. Let's see. Yeah, okay. So now, I don't know if this is necessary though, but anyway, like it's easier for me to like recall. The what's happening here is very simple, is that it's just this is your canvas. You're just telling it make a temporary canvas which is starting at 200 in the y direction and 400 which is height in the x direction, and the height in the y direction. So typically now that means that my canvas is starting somewhere here and it's going this way. So my 400 is kind of here. And then because I'm doing 0, 0, 0, minus the branch, so it's just basically making it in minus. So that's why the branch is coming out in the opposite direction, like trees, I guess. So at this point, what we need to think about is that, okay, what would happen if I had a line which kind of starts at this point here and then rotates, say maybe like, I don't know, 45 degrees or 60 degrees, and then goes this way. So I can first very quickly translate again, and now I know that it started at this point br, right? So I could just do translate to 0 br. I think that should work. And then if I do a line here, I just want to check if the line will work, and then we can try to reduce the size of it. Oh, sorry. Okay, wait. Yeah, okay. So you see the lines kind of drawn itself from right here. So after translate, if I do a rotate, say pi by 6 is what? 36 degrees. So now the branches kind of come through to the right. Okay. So now I'm also looking for one towards the left, and then I'm of course looking to repeat the whole thing. So, and so translate has this whole thing where, you know, like, so I've done a 200 to height, and then when I repeated it, the translate's already repeating itself from here to here. It's not going back from the absolute value 0 and then starting again. So I can just put a push pop kind of a format here. So I'll and then I'll just repeat the the translate can be upper. Oops. And I'll do a minus for the angle. So then I have my two branches on both ends kind of coming through. But I've still not figured out how to make that make this idea repetitive. I guess we could go back to the way we were doing it in the previous example. I also want to make the branches smaller, so maybe I can do a multiplied by into, say, like a 70. So I want them to be 70%. I'll do that here as well, right? But this is still not repeating, so how do we get that going? So I'm assuming that if we've already added branch here as 100, hopefully instead of doing line here, if we added branch as a function, it should work. So let me just try it here. Aha. So again, it is working because it's telling me that I'm over the number of calls that were allowed. So I'm just going to quickly add that here as well, and give the if statement again to be like BR should be greater than, I don't know, 3 maybe. Oops, what did I do wrong? Oh, because it's all going in minus. Okay, please help me with the math, somebody. Maybe minus should be less than, I don't know. Okay, wait. Something's wrong, na? Can somebody help me? This is basically like making it 70%, so that like the line becomes smaller and smaller. This is basically like in the previous example. If I open that separately, I have to name my files na, rather than this grape buttercup. Okay, anyway, so like here we kind of were diminishing it. So you think I've is there an issue, you think? Okay, let's just try it for one side and then maybe we'll see if it's working. Okay. Okay, so it went in the other direction. So what if I make this way? But this is going all the way into minus, right? What am I doing? Okay. Anybody can help me with the math? Basically, it's going from the first minus b. Sorry about this writing. So basically it was minus br basically means that if I gave the function branch 100, it's already passing it as a minus 100, and then like 70% lesser than that. I thought I put it upper before. I put it before the it anyway. The translate needs to be recursive, na? Otherwise how will you get the rest of the okay, BR should be greater than 2. Okay. I don't know what I'm doing wrong. 1 second. Wait, let me go into display view. So I was using this on P5 live. That's where I saved the sketch for the post today. So here, what have I done? Which is, I think I did it right. Yeah, which is length into this. Maybe this shouldn't be minus. I don't know. Let's. Okay. Clearly I did something wrong. Maybe I don't need this translate on the top. Is this what you were suggesting, Anushka? Okay. Sorry, see. That's why I need people on the stream, otherwise I'm very confused. So maybe we'll keep it here and then see if it works. There you go. So that was, thank you for, what is it called? What do you call it when you help people? Debugging? Sorry. So yeah, so we've got this one branch going on this side, and then we can just add it on the other side as well. Again, the minus is the issue. So here you go, your recursive tree is available. So I guess that was fairly simple to do. I don't know why this link isn't saving. Let me just share it with everyone. Okay. Okay. So then I just wanted to see how it would kind of affect based on different like mouse X or whatever you want to do. Like I know Anushka does, not Anushka, nee, sorry. Anurati does some very interesting experiments with the mouse X, mouse Y stuff. So perhaps she'll have some interesting thoughts on that. I'm making it a bit less dense because my computer is kind of worrying. So one could probably just do like I did it with map because it was just like seemed easier, where I added we already have a, no, we don't have a variability. So I did map mouse X, and then I mapped 0 to width, which is basically 0 to the width of the canvas, and I mapped it across. I think one could try. Basically, what I'm trying to do is the mouse movement changes the like the way the tree pans out. So basically, that basically means the angle. So right now we have it at pi by 6, which is 36 degrees. So perhaps if we could just see how it moves from, say, like 0 to pi, which would then make it 0 would be like at this flat thing, and then pi would bring it up to 90, 180. So we'll do pi by 2 maybe, and then I'll add that to the rotate here. Let's see if it works. Oh, so this needs to be minus. So yeah, so it is working. So now you have this at like, I think it's going up till 90 or something, maybe a bit more. And then when you are like around zero, it's kind of almost like a little, I don't know, pankha. So yeah, so some simple stuff. I think you can. I'm really a loser at vectors, but if you guys are really good at vectors, I was looking at some examples where they used create vector to give certain rules. So like say after the fifth step, you add like a leaf or whatever, like so that kind of stuff. So this is the basic agenda of recursion. Now, how you guys want to eventually use it for yourselves is like on you. And whatever you want to do with it. I don't know what you want to do with it. I don't know why I have a blue tree, but okay. So yeah, so that's it. And then for the post, I just added the same mouse X and I added it to text, which is not a big deal. So I guess that's not something new. Not sure, not following it sincerely. We'll just check. I think I may have upset some people about it. Where are the prompts? I don't see it. Do you? Tree, this, you think this is the one? Okay. So I don't know, Raya, if you followed last year, Abhinay did a January where he like did like percussion jam for the whole month. So there is one for coding for generative art. So it's January. So code golf wala. Oh, there's a different one. I don't know. This is the one I was using. Ha, Inktober जैसा, correct. Does Inktober also have prompts? I have no idea. I don't like follow these things too sincerely. Good one. Okay, so yeah, so these are the prompts. I'm sure some of you are. Yes, it's very much like that. Or like Nano Genmo is also another one, which is National Generative Novel, just like the Writing the Novel Month. Uh, so yeah, so I don't know. I want to experiment a bit more on how it could be used with text, perhaps, because I did see that there was like Chomsky has this hierarchy. I know white guy being quoted, and I think many people have like refuted this claim and its universality. But typically, many of the poetry generators that we make or see, especially the ones on Twitter, are made from context-free grammar, where you just give it a set of rules and a set of words. So you say, like, these are your list of adjectives, these are the list of verbs and nouns and whatever, and then place them in this way, so that there's like the article, word, whatever, like basic grammar, like so poor at all this stuff, and then it just kind of regenerates the sentences or the poetry based on that. So this is the one that I was interested in looking at. I don't know how I'll do it, but maybe I don't know if somebody is interested in trying it out with me, to do it with text, to like understand the rules and do it. But hey, like I don't know, it's not going to be visual, so maybe people aren't interested. So yeah, so this was basically what I had for today, and I don't know, that's it. We are done. I think we didn't even take an hour, which is good. Like, yeah, good. I'm like reducing your screen time, guys. uh, I don't know. You can ask Kushal because he's the one who's decided to be like my very personal reminder. I had no mood to stream today, and he was like, in the morning, he's like, "Good morning, stream today." So yeah, code golf is like how little code can make something interesting. Oh, Abhinay, was it you who sent this very beautiful one called Tixie Land? Where like you can, is this it? Code golf? But I don't understand these, like, I don't know how to do this fat arrow function. So, how would I? No, I don't know anything about code golf. But why is it even called code golf? Because it has goals. Because it's recreational. Aha. Okay, okay. Good rabbit hole. Uh, okay. So yeah, this is what I had planned for today. Like, I don't know now if you guys want to do something more. I don't know what we would do. I don't know, recursion in 3D. Don't want to attempt it, but this is really weird that it's not giving me any link for the saved. Valuable. Oh yeah, like isn't that almost all dads? We have a we have an internal joke in our family that our dads have resting grumpy faces. So okay, so that's about it. Is there anything else? What is RGF? Guys, I'm so behind with this stuff. Okay. What, Kushal, you want me to try something with this? Okay, something quite insane is happening. But is it even recursive? I don't know. Oh yeah, it is, na, because yeah, it is recursive because then maybe we'll but there's no way to stop it. Okay. Okay, I'm leaving the tree back as it was. अच्छा ओ ओके ओके सॉरी सॉरी तुम्हारे जोक्स बहुत हाई लेवल है यार मैं तो लाइक मम्मी कैटेगरी वाली हूँ ओके सो दैट वाज इट इफ यू I don't know what you guys want to do next time. You can let me know. I don't know if I'll be able to accomplish it, but we can try and like let it fall flat on our faces. Okay. Okay. Bye. नहीं नहीं मैं नहीं कर रही टिम रॉडन ब्रोकर जैसे उसको करने दो वो जो कर रहा है वो बहुत पैसे कमाता है इस काम से मैं नहीं कमा सकती तो एनीवे लाइक no it's a live stream that stuff doesn't happen on live streams maybe you can make it for me Raya like some uh, music for the bye yes okay cool okay, thank you guys for joining and sticking around. We'll see you next week, maybe. Thank you for coming. Sorry about the timing, but this is all I have. Bye. And don't miss my files in the back. Yeah. Okay. Bye.